This time, we will look at the building detection with liNear and Revit. We use this example project of an office building with about 1,600 square meters for about 60 workplaces. Both the architecture and the structural model are loaded as a link in our project. On this basis, we have already set the MEP spaces for the MEP design, which I've already shown how this works in one of the previous videos. So we have 3 floors, and now we want to analyze the building in order to continue, for example, for the heating and cooling load calculation in liNear building. In the liNear control board, we find the building detection in the analysis tab of the architecture discipline, and we can make some specifications before we start it. If we have included a topography in the model, as in our case, we can activate the analysis of this topography within the detection of the building. If there is no topography, I have the possibility to specify a reference level in order to preset a ground level. If Revit curtain walls were used in the architecture model, I can still specify here how these are to be captured. So whether the curtain walls are to be analyzed as a single component, the curtain walls are merged, or should be transferred to liNear building as individual windows. In our model, no curtain walls have been used, so this is not important for the detection here. In the lower part, we define which data should be transferred from the model. These are thermal component properties, already created load profiles from the MEP spaces, or also the ventilation data. If I have created several building parts in my model, I can also transfer this information, which is not the case in our model. Finally, I activate the saving of extended component information, which enables a better visualization later on. Now we start the building detection, and liNear building opens automatically, where I then start the model analysis. Now all rooms are searched, building components are assigned to the individual rooms and stories, and all intersections are calculated. A correction of the net areas to normative axis dimensions also take place. The program now also checks the model itself and informs me of any modeling problems. The building is now detected, and the building structure with all rooms and components can be found here in liNear building as well. I now arrange the windows side by side and use some special situations to show you the performance of the detection and the interaction between liNear building and Revit. I can now display all detected rooms quickly and easily via the Show Cut Element function with a click on the magnifier button. For this, it is recommended to set the display to hidden lines as well as the architecture to semi-transparent. So I select the room in liNear building and start the function. Now we see the room highlighted directly in the model, and this also here in the 3D view. I can also activate this show function permanently, and then the currently selected room is always displayed. Especially with large models, it can of course happen that a room is not well visible, as for example here with our lobby. In this case, the 3D selection box function in the liNear control board helps to view this room isolated. The lobby shows another special feature of the building detection. As you can see here, the lobby consists of 3 partial rooms. For the transfer to liNear building, these were usefully merged by marking the upper rooms as airspaces. If I now switch to another room in building, Revit automatically switches to a suitable view in which the selected room is then highlighted. So you do not always have to have a suitable view active, because the program recognizes this automatically. If none of the active views is suitable, the program asks you whether it should search for and open a suitable view. As you can see, a floor plan was selected in this case, since this function also works perfectly in floor plans. Again, I select any room in liNear building and it will be highlighted immediately. With this function, not only rooms can be highlighted graphically, but also single components. Let's look at this again in a 3D view on the ground floor. So if I select a window, an interior wall or floor in one of the rooms, I immediately see their equivalent in the model. In the case of walls and floors, you can also see here that only the part that is also assigned to the respective room is highlighted to us. The segmentation of the surfaces that is created at room level can thus also be found again in the model, and in this way I can very quickly and specifically target specific rooms and components in the model, and, as already mentioned, this also works in linked models. This interactivity between liNear building and our Revit model also works in the other direction, which means that I can also display the individual rooms and components in liNear building out of the model. To do this, use the pipette button and select the component in the model. This also works in the 3D view as well as in floor plans. To simplify the selection, you can use the Tab key as usual in Revit to switch through the components in the selection area. Here again, the program recognizes partial sections of surfaces, for example, this wall segment, and display it to me in the corresponding room in linear building. In case of components that adjoin two rooms, the selection direction is crucial. If I rotate my model and select the same wall from the other side, this component will be displayed in the other room in linear building. So the room from whose side I select the component is always chosen. This is how detailed building detection and the resulting interactivity between linear building and your Revit model works. That's workflow instead of workaround.